In C#, if you want to use the for each loop to iterate over something, this something needs to implement the enumerable interface. This interface declares only one method, returning an enumerator, which, as the name suggests, is meant to enumerate the elements of our thing. This is how its interface looks like. Under the hood, the loop will invoke getEnumerator, store the returned object, and use it to iterate. It will first call moveNext, which is meant to prepare the next element of a collection. Then it will use the current property to retrieve said element and assign it to this variable. Lastly, it will execute the body. This whole process will repeat until moveNext returns false, which means that we've reached the end of our collection. Now, we've gathered here today because at some point, somebody got an idea to describe this concept of enumeration using a function, where instead of returning just one value and then finishing, we could continue to return subsequent values for as long as we want, essentially enumerating them. This idea is prevalent in many different languages under multiple different names, but in C# we call it an iterator method. It returns an enumerator and uses yield statements to either return another value or to signal that the enumeration has finished. It may seem counterintuitive, but when we call such a method, the code inside does not execute. Instead, a new enumerator is created and returned to us, and we can use it to enumerate. Calling moveNext begins execution. When the yield keyword is encountered, its value is assigned to the current property, and the execution stops. Now, if we call moveNext again, our method will again begin execution, but it will pick up exactly where it left, continuing until the next yield statement. And we can repeat this process until we reach a yield break, or the end of the method. But the fascinating thing here is that we've just declared a method that can be paused and then resumed. Coroutines in Unity leverage this ability to allow us to write asynchronous code. We start a coroutine by calling startCoroutine with an enumerator as the argument. From now on, Unity will call moveNext for us, but we can influence this process by yielding different things from within our method. In fact, there are three main things that we can yield. First, there are yield instructions, like wait for seconds or AsyncOperation. They instruct Unity to resume our method once some amount of time has passed or some process has ended. Another thing we can yield is a different enumerator. The effect will be similar to calling a method. Unity will start executing this new enumerator until it finishes, and then it will continue with our initial enumerator. Finally, if we yield anything else, Unity will do nothing and try to call moveNext again during the next frame. And as with the for each loop, once moveNext returns false, or in other words, once we yield break, the coroutine will stop. Knowing all of this, let's take a look at an interesting issue related to coroutines. Imagine that we have two tasks that we want to run concurrently and wait for both of them to finish. If we do something like this, we'll end up running them one after the other. The solution here is to run them as separate coroutines. StartCoroutine returns a coroutine object, which is also a yield instruction. So we can start the task at once and then wait for both. But what if we want to wait only for whichever task finishes first? With AsyncOperations, we can easily do that by checking the isDone property. A coroutine object does not have a property like that, but we can easily fix that. I'm gonna start by creating a new class called coroutineHandle with an isDone property. I wanna be able to yield it, so I'll implement the enumerator interface. moveNext will return true as long as the coroutine is not done. In the constructor, I'm gonna need two things: a monobehavior that will start the coroutine, and an enumerator that I wanna run. But instead of running it directly, I'm gonna wrap it in yet another enumerator. This one will simply yield the original and then set isDone to true. Lastly, I'm gonna assign the newly created coroutine to the current property. This way, if we decide to yield this handle, it will pass the original coroutine object back to Unity. As a final touch, we can create an extension method to make things less verbose. And that's pretty much it. We can now use this method to start the coroutines and use isDone to check if both are running, and proceed with the execution once at least one of them has finished. This concept can be, of course, further extended. We can, for instance, add an event that will notify us when a coroutine finishes. Possibilities are endless, unlike this video. So thanks so much to all my patrons, thanks for watching, and until next time.